This video is about angles of elevation and depression. Angle of elevation is an angle formed between an observer's horizontal and line of sight when looking up. Okay? Here's a diagram. So, the horizontal is an imaginary line that is in line with the observer's eyes. And the line of sight is an imaginary line from the observer's eyes to the object the observer is looking at. In this case, the observer is looking at a bird. So the angle formed between the horizontal and the line of sight when looking up, that is your angle of elevation. Okay? Alright. Angle of depression. Angle of depression is an angle formed between the observer's horizontal and line of sight when looking down. Okay? So again, this is the observer's horizontal. Alright? That will always be in line with the observer's eyes. And the line of sight, that is from the observer's eyes to the object the observer is looking at. The observer is looking at a rock in this case. Okay? So the angle formed between both lines, that's your angle of depression. Okay? Alright, let's look at another situation here. Now this situation is when the angle of elevation is equal to the angle of depression. And that only happens when both observers share the same line of sight, meaning that they're looking in each other's eyes. Okay? So for example, this person is upstairs talking to this person downstairs. Usually when people are talking, they look in each other's eyes for courtesy. Okay? So they would share the same line of sight because you're looking in each other's eyes. So this person at the bottom, this is the person's horizontal, this is the person's line of sight, so the angle formed between them, this is the angle of elevation, because the person is looking up. The person at the top, this is the person's horizontal, this is the person's line of sight, and this is the angle of depression, because the person is looking down. By virtue of both of them sharing the same line of sight, then it means that angle of elevation is equal to the angle of depression. These two angles are the same. Okay? Let's look at an example. So example 1. From a point on the ground 12 feet from the base of a flagpole, the angle of elevation of the top of the pole measures 53 degrees. How tall is the flagpole? Whenever you're given word problems, always draw a diagram to represent the situation. Alright? So here's my flagpole. Here's my flagpole. Okay? It says from a point on the ground 12 feet from the base of the flagpole. So here's the base of the flagpole. And here's my point on the ground. Okay? Whenever vertical meets a horizontal, it meets at right angle, 90 degrees. Okay? So this is the point of the ground. On the ground. The observer is here looking up at the flagpole. The fact that they did not tell us what the observer's height is, we're not going to draw the observer. Okay? So this is the observer's line of sight looking at the top of the flagpole there. So this would be the observer's horizontal. This is the observer's line of sight. So the angle of elevation would be right here, which is 53 degrees. Okay? And they told us that from a point on the ground 12 feet from the base of the flagpole. So here's the base of the flagpole, here's the point on the ground, so this part is 12. And now they're asking us how tall is the flagpole. This part here they're asking us to find. So that's your diagram. Having gotten your diagram, the next move is to label your diagram. Okay? Remember that any side that is across from your given angle, this side is your opposite side. Okay? Any side that is across from your 90 degrees, that is your hypotenuse. And of course, the side that meets the hypotenuse to form the angle, that is your adjacent side. Alright? So having done that, we're going to look at the side that was given to us. The side that was given to us is our adjacent. So I write A to represent adjacent. The side that they want us to find is our opposite side. So I write O for that. Then I go back to my SOHCAHTOA. So my SOHCAHTOA, then I'm looking at, of these three, which one ends with O and A. And I see that that is tan. That is tan. Okay? So this would just be tan tan theta, the theta is the angle here, which is 53. So that is tan 53 degrees equals opposite, which is x, divided by adjacent, which is 12. Okay? Now, I want to get rid of that 12 from the denominator there. So I'm going to multiply both sides by 12. Having done that, this 12 in the denominator will be cancelled with that one there. So what I'm left with is 12 tan 53 degrees equals x. Now, I can put all of this in my calculator as is. Make sure that your calculator is in degrees. Okay? So to test that, you can hit sine 30 just to test, and if you get 0.5, you're safe. Okay, we're good. Now I'm going to put this in my calculator. So it is 12 tan 53 degrees, and that is 15.9. Okay, and I can round that to the nearest whole. If they ask you for one decimal place or to the nearest tenth, you would write 15.9 feet. Okay, or if they say to the nearest whole, you would write 16. So I'm going to put it to the nearest whole. So this is 16 feet equals x. Therefore, the height of the flagpole would just be 16 feet. Okay? Alright, let's look at example 2. Example 2 says, from the top of a vertical cliff 40 meters high, the angle of depression of an object that is level with the base of the cliff is 34 degrees. How far is the object from the base of the cliff? Alright, again, we're going to use a diagram to represent this situation. So here's my cliff. They say from the top of a vertical cliff, this is my vertical cliff, 40 meters high, so I put my 40 here. The angle of depression of an object that is level with the base of the cliff is 34 degrees. So here is the object. The object is right here, that is level with the base of the cliff. So remember, vertical meets horizontal at 90 degrees. So here's the object. An observer is at the top of the cliff here, looking at this object. So we need to know, we need to represent the observer's horizontal. So because they did not tell us what the observer's height is, we're not going to draw the observer. Okay? So I just represent the horizontal of the observer. So this is the horizontal of the observer, and this is the line of sight of the observer looking at the object there. Okay? So the observer looked at the object at an angle of 34 degrees. So this would be the angle of depression here. That is a 34. Okay? But remember that if the observer at the top looking at the observer at the bottom, and they both share the same line of sight, then it means that they share the same, they're looking at each other at the same angle. So this is what you call alternate angles. And alternate angles always form the letter Z. So do you see this Z? So this angle is the same as this angle. Alright? I could use this diagram, or I could clean it up a little bit and draw a different diagram. So here's the completed diagram that I'll be using. So this is my 90, this is my 40 here, this is my 34 here. Okay? And they say, how far is the object from the base of the cliff? So here's the object, here's the base of the cliff, they're asking us to find right there. Okay? So again, what we're going to do is label our diagram. Across from your given angle, this is your opposite side. Across from your 90, this is your hypotenuse. And this part would be your adjacent side. Okay? So, they gave us the opposite side, so I write O. They asked us to find the adjacent side, I write A. And if I go back to my to, I realize that tan is the one ending with O and A. So it would be tan theta in this case is 34 degrees, equals opposite, which is the 40, divided by adjacent, which is x. Again, I want to get rid of that x from the denominator there, so I multiply both sides by x. Alright? And this x will take that one out from the denominator. So what I have left is x. Let's take it up a little bit. What I have left is x tan 34 degrees equals 40. But remember that tan 34 is a number. So I'm going to divide both sides by tan 34 degrees. Okay? And that part takes out that. Let's take it up here. So x equals 40 divided by tan 34. So I can put that part in my calculator. So I use my parentheses. So it is 40 divided by tan 34 degrees, and that is equal to 59.3. Okay, so if they say to the nearest tenth, that would be 59.3 meters, or to the nearest whole, I'm going to put mine to the nearest whole, which is just 59 meters. So this would be 59 meters there. Okay, and that would be the distance of the object from the base of the cliff. Have a great day.